Welcome to Renaissance Charge videos again. I'm Rick Friedrich, and we're going to talk today about the next phase towards a free energy world, the protective shielding enhancements. Now we're also going to talk about several other things today, so I want to go over those things first. First of all, let's go over what we're going to talk about today. We're going to talk about, again, the Benitez system as I was running it before on this induction coil, and then we have another one here that we're going to look at. Then we're going to look at the type of energy that's produced here and what it is that is necessary to create a free energy system. And of course, we're going to look at a shielding over here, how to properly shield this, because we want to shield it for safety reasons, and actually we want to have an amplification system out of it too. So I figured that out some years ago, and I haven't gone around to it till more recently. And we're going to look at the Tesla coil. We'll look at some quotes from Thomson, G.G. Thomson, and Hertz and Tesla, and some from Don Smith. So let's go over first of all the system here that we had gone over before. So what we have here is two battery banks, well actually, yeah, two battery banks, 24 volts, and this is what we covered in the first and second video, third video actually, of this series, which is part of the first free energy patent series. So this is going to be a continuation, and we'll have probably quite a few more videos in this series. So if some of you have been disappointed about this series because it hasn't given you everything you're looking for, it's because there's a lot to cover. And there's a progression to this. This stage is going to be probably the most important of all. I know I keep saying that, but it is, because this shielding makes this technology usable and safe. And that's a key thing. Anyway, we covered this already, and I'm going to just mention briefly. This is 24 volts going into 12 volts. They're 12 volt batteries, and these two are in series for 24 volts. These two are in parallel for 12 volts. So we're going to run this coil in between the two positives here, and here, the red wires. And we're going to run a little inductor and two bulbs there. That's going to be our output, and we're going to run this. We're going to charge up these batteries while we're running these two batteries. And that's what we did. I was running it for a while, so the batteries have been charged up quite a bit here. They charged very fast with this system, and of course there's some tuning obviously involved in this, and I haven't bothered to tune this particular one to any ideal tuning here, but I want to again go over the basic system here. So what we're looking at is running this induction coil. Induction coil is, there's a primary and secondary winding inside. I've gone over that in the second video, so you can look at that video for the details, and you can look at this following picture. In which you'll see the schematic layout of the connections again. So what we're doing differently is normally there's a capacitor across the 12 volt input, or whatever voltage is actually only supposed to go up to 10 volts, and the other side of the contacts on the make or break contact there. And there is actually a bunch of capacitors here which I have bypassed. And so what I'm doing is what Carlos Benitez in 1915, in one of his first patents, what he said is an improvement. And I'm running this capacitor, that's a 10 microfarad capacitor, across the negative terminal here, which is in between the two battery banks here. So what we're calling the splitting the positives, so to speak. We're running between the two positives for the, in this case, 12 volt potential difference. So now, and in between, on the output, we're running this coil with these two bulbs. So we still have the spark gap across the secondaries, and I'm actually not even using the secondaries. So we're just using one part of the system. We're going to just waste the energy here in the spark gap. So we can run a load between these, and that's not my objective today. But I just wanted to show just another model running this. And this is one that you can buy. It's very hard to get this. This is one of the last ones available from this one source. There was another one I wanted to get, but they don't sell it anymore. They're out of stock. So this is a pretty good coil here, but you're not supposed to run it more than 10 minutes, so they say. So I think if you tune it down, you could probably run it continuously. But so what we're going to look at is, this is the amp meter, and it's not going to be accurate because there's a lot more energy being produced than it can really recognize. And we're not really looking at amps as our, in a system like this, it's very difficult to meter that. But we are going to consider the resting voltages on these batteries. So you can see this one should come down quite a bit because it was being charged for at least 10 minutes. And this one's come back to where it was, 24.1. So that will drop under load, and this will charge. So this is a very, very good and effective charging system, as well as a load. What we'll do in the next time we run the Benitez system, we'll do the final patent. We can use this one with its open secondary. See, the other ones that I have here, all these older ones, all the primary and secondary connections are all connected, and so I want the isolated connection there. Turn this back to meters time out on me. So on the final patent, we'll see these running where you have just one 12 volt battery going into another 12 volt battery, and then we run a load off of the 12 volt battery, the first one, and then we recover all the energy in the charging battery, just like the Ed Gray system later on. So let's look at this for a little bit here, and let's run it, and you can see, so you can see there's a spark gap there. When I open it up, you can see how it affects the charging rate. So not too much. So now it's open. There's an open, there's a very little spark gap between there. So actually we don't really want to see a spark at all, ideally. We want to see like a plasma in an ideal situation. The spark sparking, we want to actually blow it out or use magnets to magnetically quench it, and we want to shorten that as much as possible. But this is dangerous. It's not highly dangerous right now because it's running very low, but it's producing ozone and some other gases. We're going to talk about that shortly. So I just wanted to show that this is indeed charging these two batteries here, and of course it is discharging the primary. But because of this extra wire, this capacitor going across these terminals here, this terminal and the, as shown in the patent schematic, because of that we have a difference. So you can see when I take it off, the amperage goes way up on that, and even then it's not going to give you quite accurate results there. Of course that charging rate goes up too, as it seems to show, but so anyway, it's a matter of tuning this in the right place and doing the right things. I should be using the secondary winding on this, but I'm not. And actually in the patent it shows that one of the primary and secondary windings are connected in this one. But anyway, I just wanted to show it basically, and we'll just turn it off now and we'll continue on here. But you can see, you know, it's still holding out. It's going to come down quite a bit, and we can look at those voltages over time here and see. But I just wanted to cover that briefly. We're going to show this, and there'll be a demonstration that will be very thorough, and it will be actually a product that we can make for people, or they can make it themselves. And you know, that will be one system, just like our motor systems. But right now, to buy one of these induction coils is not easy to do. Unless you get this one brand new. These old ones, they're hit and miss. Some of them are really bad condition, and some of them just really can't even be fixed. But most of them I got were usable. But you can use a neon sign transformer as well, like we have over here, a big one, and then we've got you know, other ones right here. So that would be one kind of alternative. You can also use the same circuit that's in these globe, and we'll look at that in a minute, or the Tesla coil circuits. So we can use a variety of alternatives here. So let's go over something very significant. I want to mention something here. This is from Don Smith. This could be debated out. I'm sure a lot of people don't realize this or would not believe this, but quote, "The number of radio sets and television sets running at any one time do not diminish in any way the electrical output of the source station." So radio stations have to pay to send out a signal. They have to consume so much energy to broadcast. However, it doesn't matter how many receivers there are. They're not directly linked to the broadcasting station. So in other words, you could put as many receivers as you want out there, and they would be able to receive the message within the area of the radio transmission. So they're consuming an amount of energy to broadcast to a certain area, and within that area, if you have, for example, crystal radio sets, you do not even need to have power source. And that is something to look into, of course. It is very interesting, the crystal radio, because it operates on the same kind of principle of what we're doing in these free energy systems. It is not the radio station that is actually powering the crystal radio either. And that is what people don't understand. And of course I know there'd be a lot of debate about that, but this is something from Don Smith, and what's critical to understand about this and the Tesla coil and so forth is you got to look at it as a radio transmission. A radio transmission does send out a signal, and in these kinds of systems, like we've been doing with batteries and these other higher voltage systems and higher frequency systems, we are making it possible to create a signal and have multiple receivers. So for example, if you made a Tesla coil the right way, and you had far enough away, or actually not even too far away, a whole bunch of receivers that are tuned resonantly tuned to the Tesla coil, the main source, then you would actually have as many receivers as you want without diminishing the input to the Tesla coil. So now if you get close enough, then you can have a different kind of relationship with the Tesla coil there, the primary source, and that will possibly diminish the, it will affect the primary in that case. But if you're far enough away and yet you're still in the vicinity, as many of these Tesla coil receivers as you put out that are identical and identically tuned in resonance, they will actually receive this power and you can run loads off of. So in the same way, we can do this, and especially we can enhance our output with the ground connection. And the ground connection is something I'll go over at a later date, and how that is additive. This is something that most people do not understand, is the ground system. And they think of it as a physical ground, and it doesn't need to be. It can be a big ground, such as the frame of your car or an airplane's frame. This can become an air ground. And so it's not so much the earth ground, which has a lot of potential, of course, but a big enough body, such as a big piece of metal. You know, the bigger, the more significant it's going to be. So we're looking at voltage potential differences, and we're going to run systems off of that in a variety of ways. So what I'm talking about, again, going back to the radio frequencies and the output in this, what is it? Now I'm not, again, a stickler for all the definitions of these various words people are using, or to actually claim to know the exact way things are operating. There's a lot of debate, and people define their words differently, and I'm not going to be sticking to one definition or another. People like to use the word radiant energy or quantum, quantum terms, quantum physics, 0 point energy. These are not important terms to me. There are zero voltages, and there are phasing, like we talked about, where we create a negative energy output with our motors, and we have a positive energy input into the motor, and we phase those two types of energy out of phase with each other, and the voltmeter can read 0, the ammeter can read 0, and we still have power. So we can call that maybe 0 point. It's not so important to me. But what I'm going to be talking about more today is this type of energy, whatever it is that permeates the air. The whole air gets electrified. And this is happening only with an open loop system where there is a spark or a transistor switching on and off. And what happens is you can just feel it. The whole area gets electrified. If we have a little neon bulb, we can, like this, we can, this batteries are dead. Anyway, we can make a neon bulb light up in the whole area. And why is that? I can touch a piece of plastic with one hand holding one leg and touching a piece of plastic and it will light up in the area. Or it can just light up by itself without touching anything. So, like the other day I had a little spark gap tube running and it was lighting up the spark gap tube without it touching anything. It was just lighting up. There was arcing between the gap. So what's happening there? Today I want to talk about safety, but I also want to bring up the idea that the whole air is becoming electrified. Now you get various authorities that like to oversimplify things. And the first place where it was oversimplified, this type of energy, was in Maxwell's equations back over 100 years ago, where Maxwell's equations became more simplified for convenience. And, you know, there's, I suppose, a conspiracy to eliminate the free energy processes for the purpose of selling power and controlling people. So forth is something that I'll get into when I write my chapter in my book about all of this stuff. I'll get into how it started, who are the players, and just the innocent reasons for the way we have our systems today, and why other people supposedly conspired to make it more difficult for us to have a self-sufficient system instead of having to buy power. So what we want to do is get into that in the future. But I don't have the time right now in this video. I don't want to make this video too long. So the point is, at some point, this happened, and people oversimplified things. So basically we have today, we talked about a year ago, the flyback diode, the snubber diode across an inductor when you're pulsing a motor. We talked about how that was a closed loop system to destroy the potential energy, to make it convenient so the parts don't blow out, was the innocent reason, but also to not show people what you can do with this. When you're talking about electrostatic energy, this is not considered, whenever you look up anything related to that on the internet, in books, wherever you want to look in these authorities today, it's not practical energy in their definitions, in their descriptions. They just simply say it's a curious thing, it's used in some applications, but it's not practical. Well, it is. So they'll say things like, oh, you can rub your feet on the carpet and touch something, you get a big shock. But you can't use that energy. And so everything is just this whole aspect of energy, which is really the second part of it, is totally ignored and just brushed under the carpet. So what you find is, oh, it's a curious thing that the lightning strikes. Oh, it's a curious thing, but we can't do anything with it. Well, there's supposedly, what, 200,000 lightning bolts striking the earth every day, 24 hours, which represents quadrillions of joules. I don't have the exact number in front of me. Well, this actually can be, this sends out a huge signal, a magnetic signal, which I'm going to show with my meter, an example of that shortly, my Gauss meter. So what happens is we can tap into that. Now, Tesla's 1901 patent, he has the outline of how to collect that. Now, it's not everything that you need to know to make that the way he was intending, because he didn't show you everything in that patent. But there is a way to collect that type of energy. And what we're doing in these systems is we're making that happen ourselves. We're creating the lightning bolt, so to speak, and we're creating a system where we can collect the energy. And that's very important. But before we do that, this is not healthy. And before we do that, we're going to, first of all, this video, that's what this video is about, is show you a way that has to be shielding this to help you. So let's go on here with some different things. Just want to get rid of stuff here. So let's look over the dangers of a Tesla coil. And we talked about this before. This is really important to understand. There's a website here called pubmed.com safety.htm, and I'll send that link on the page here. And this is back from 1996. I've already mentioned this before. But there are numerous dangers in a Tesla coil, especially the bigger ones. And to run a Tesla coil with a lot of input power is really not necessary. If you really know what you're doing, by the time we get to the end of this video series, you'll understand what I'm talking about. We don't really need a lot of input power, but that's what people are doing today. But anyway, when you do that and you have like 220 at high amperage going into your system, we have a lot of serious concerns. And others, as I said, will mention that. You can look at this link and look through them. But I want to talk about even running a very small system such as 1 watt, half a watt, 1/10 of a watt, 1/100th of a watt. We can run a Tesla coil and we can still produce things that are negative, that are bad for us. So one of the things that can happen in, for example, the spark gap part, is we can produce ultraviolet light and X-ray production. We have radio frequency interference, which then also can affect our electronics. We can destroy this computer if I was to leave it here or run a powerful enough system. I would ruin this quickly, and my cell phone and whatever electronics in the area can be destroyed. Because what we're doing is we're sending out a signal again, and it creates this like electrostatic field almost. This whole the whole area becomes electrified. I'm not using all the technical terms here because I'm not doing these videos for the real technical inclined. So I'm just going to use some basic words here. Anyway, the point is, we saturate the area with this energy, and what happens is it will create streamers everywhere. So in your electronics, it will create a jumper between traces and make your microchips, your programs be erased or ruined. So you have to be careful, you have to isolate it, and that's what we're going to talk about with this shielding here. And I'll tell you about that in a minute. So we create radio frequency interference, but we also create gases. We create ozone, and let's read a couple here. Nitrogen, oxygen compounds, a whole bunch of toxic substances. Of course, depends on what the local area has, but between the spark gap and even on the items that we're energizing and connected to, we can create this these gases. So in order to do experiments with this, we got to protect ourselves. So now we can also produce ultraviolet light and X-ray, and this is very bad for your eyes and your cells in your body. So again, going back to 100 plus years ago, 120 years ago, you had the discovery of X-ray, and you had people immediately using the benefits of it so that they could actually see internally in the body. Great, we still do that today, their teeth, but exposure to that led to, you know, cancers and so forth, and the original people that did the testing died. And it was a shame because this is the kind of thing I warned about in a previous video about Tesla, you know, how he encouraged these kinds of technologies without carefully testing them. And I have quotes here where he actually said, don't worry about it, it's not going to harm you that bad, which it did. So you can't trust anyone. I wouldn't trust anyone with any technology, to tell you the truth, until you test things out. And that's what this video is about. It's about a safety. Safety first, test it out over years to see if it's healthy before you introduce it into society. So that's why this is the primary goal of mine, first of all, is to create something that's safe. So we could talk about this all day long, but I'm not going to. I'm just going to get into the solution. So let's go on our next point here. The other thing, actually, I should say is there are chemical hazards, explosion hazards, noise hazards, burns. You can burn yourself with this, not just shocking yourself, but as you create with different frequencies, different voltages, and doing different experiments relating to high frequency, high voltage, you can burn yourself and not even realize it. Once you get up to a higher frequency, you can't sense it anymore. Your body cannot sense things, and so it can go right through you. You can damage your internal organs and not even realize it. And you can burn yourself. People make a joke about, oh, you can, burn yourself with this. This is one of those globes. Oh, you can burn yourself on this, or, and laugh about it, right? Play around with this. This is not healthy for you, and it's not good to burn yourself. You can have severe burns from that very easily. So, these are not toys. They shouldn't be toys. They should never have been toys. This is not good for you. Now, there are healing devices, such as the violet ray, which we'll look at in a minute. We've talked about that several times. And there are other methods of using this high frequency, high voltage systems to pinpoint pathogens in the body and try and eliminate them. And these things do work. But the exposure to the other negative effects may not make it worthwhile to do. So you have to weigh that out and be very careful. So there is a way to deal with this in a way, again, that puts it in the box, keep it more safe. So we've got to balance things out. Of course, cell phones are not good to put to your head. Radiation from the microwave is not good for you. So, but we use these technologies for convenience. But I think when we're getting into this stuff, we're on a whole different level of danger, and we can very quickly hurt ourselves and very quickly develop cancers. And I think right now we're at the stage where just about every area in life we're being attacked. We're being attacked with our food, with our chemical environment, with our electrical environment, and obviously in all other areas of our lives too, we are being attacked. The person, the soul is under attack. And so what happens health-wise, because our immune system is broken down because of all these factors, we're much more susceptible to developing cancers and so forth. So we have to do whatever we can to ensure a safe environment as possible. So let's go on to a couple of things here. Let's go into the box. So what is this box? Well, years ago, I knew that this energy was a problem. If I produce a motor, because I used to be a mechanic, and of course I have produced motors for vehicles, and I've shown at least 2 boats running off of these motors that I sell. What we call a magnetic motor, the industrial motor. We had it on several boats. The problem with this kinds of system is it creates this, it saturates the area again with this pulsing that can destroy even your multimeter over time. So I knew if we were going to do this for a vehicle, a commercial product, I had to develop some kind of shielding. And so I'm not going to show you everything that I'm going to do, but I figured I needed to show you something if I'm going to promote any of these higher voltage, higher frequency systems. I'm going to show you something that will work for now. And so this is only one part of the final process. Because the final process will be the ability to not only shield from the negative effects of this technology, but it will also be receiving as an antenna. It'll be a receiver. So it will multiply the output while protecting you. So it'll be a mutually beneficial process. But for now, what I want to talk about is something that, whoa, I almost dropped something inside of here. So what we have is a wooden box covered by zinc. So I want to show that in a second here. Where did this idea come from? So we're going to go over a couple of sources here. And of course Tesla gets credited with everything, even though he was not the source of it. So what I want to do is quote both Tesla and oh yeah, I should have quoted this earlier. So where we talked about this in the induction coil a little bit, but where did this whole idea of this different kind of energy come from? Like when I say different kind, I mean it's not a closed loop and it creates all these streamers that saturates the whole air like we're talking about. Where was the first reference to this in modern history? I'm not talking about ancient history because we don't really have too much information about how they did these things thousands of years ago. And that they did them, to me, seems pretty manifest from for a lot of reasons. So I want to go back to, I think it's 1871. Yeah, July 6, 1871, from Professor Edwin J. Houston. And I think he's quoting Thomson. And the Journal of the Franklin Institute, and I'll show the source of this. The following experiments were made at a Central High School of Philadelphia with the view of increasing the quality of the spark of the induction coil without greatly diminishing its length. The instrument used was made by Ricci of Boston and will throw the spark 6 inches in the free air. So if we had that violet ray device, or like a Tesla coil, you could see the streamers come off of it. So we could do that here too. So one of the poles or ends of the secondary wire was connected with the earth ground, by a copper wire attached to a gas pipe. Look out. The other pole was connected with the wire which rested on a large lecture table. Right? So then on turning the brake piece, the electricity, instead of being lost by passing along the wires to the earth, jumped from the pole connected with the table to that connected with the earth. The thickness of the spark was greatly increased, its length diminished, and its color changed to a silvery white, as when the Leyden jar, the capacitor, is placed in the path of the discharge. While electricity is flowing between the points, long sparks may be drawn from any part of the table, or from any metallic article within 8 or 9 feet of the coil. This is what we were just talking about earlier. On one occasion, the gas was lighted by a spark drawn from the finger of a person standing on the floor. This is very dangerous because if you do it just right, you can create a lot of amps in the system and kill yourself. So it may seem innocent enough, but be very careful to understand what you're doing before you do any of this. The gas pipe being in almost perfect connection with the earth, the spark must have been given to it from the body of the person. So the person becomes an antenna. On another occasion, one wire was attached to the gas pipe as before, and the other to a stove, whose pipe connects with that of another stove in an adjoining room. The thickness of the spark was greatly increased. Sparks were drawn from the distant stove, and even from a small steam engine, which later was fully 30 feet from the coil. In all the experiments, it was found necessary to insulate the handle of the brake piece, as a slight shock was experienced at every brake. The poles being kept at a distance from each other, less than the insulating power of the coil, 6 inches, no danger of injuring the instrument was apprehended. In one instance, the sparks were drawn in a room underneath the adjoining room from a wire which connected with the table on which the coil rested. These facts showing great loss of electricity, in their minds, but indicating the need for a large conductor, probably to allow the rapid discharge of the secondary wire. A large insulated conductor was extemporized by placing some old tin stills and percolators on large glass jars. On connecting one of the poles with this conductor and the other with the glass pipe, the quantity of the spark was increased, though there was reason to believe that with a larger conductor, better results would have been obtained. So you can see that they didn't really know what they were doing yet. They were just guessing. This is like the first time it was written in the literature that this phenomenon was taking place. This is what Tesla had first read. There was 2 sources. This was one story. The conductor was then divided into 2 of about equal size, which were connected with the poles. The quantity of the spark was increased, with, however, great diminution in the length. But by successfully diminishing the size of one of the conductors and increasing that of the other, the length of the spark was increased, without any sensible diminution in its quantity until, when one of the conductors was less than 1 square foot in surface, a fine quantity spark of about 5 inches was obtained. It will be noticed that this connection is somewhat similar to that used in the common cylinder or plate machine, in which one of the conductors, generally the negative, is connected with the earth, and the quantity of electricity thereby increased. So, okay, let me finish up here. In all the experiments in which one pole was in partial connected with the earth, as when it rested on the table, the loss of electricity must have been very great, for several gas and water pipes are in connection with the table. If then the table merely serves as an imperfectly insulated conductor, which allows the rapid induction of electricity in the secondary wire by its rapid discharge, and thereby notwithstanding the loss, gives so great an increase in the quality of the spark, it would seem that if, instead of the table, an insulated conductor, a very large surface were used, a much greater increase in the quantity would be obtained. So again, they're thinking like people today of it in the wrong sense. It would seem from the above experiments that the maximum increase will be obtained when one of the poles is connected with the insulated conductor, say several hundred square feet in surface, and the other with the earth. So that's the end of that. So what the point is of me quoting this again is to show you that the whole area becomes saturated with this energy. And I'm going to show this right now. Well, I'll show it in 1 minute, the next thing after. I'm going to go back to now 1893, Henry Hertz, his book on electrical waves. So he writes in here about an experiment that he had done previous. So there's too much to quote in here, so you can read, and I'll probably quote in here some miscellaneous quotes in the final edit here, but I want to quote this because we're going to talk about this box here and this whole idea where this box came from, the zinc box. Now it can be shown that a closed metallic envelope does not allow the action to pass through it at all. Now this action is what we're talking about. This, I mean, you can call it a field, but it's not a regular field that you normally think of. this whole electrifying the area. Now he says if we have a metallic envelope, it doesn't allow it to pass through. So if we place the secondary conductor in a favorable position with reference to the primary, so it sparks 5 to 6 millimeters long, so that sparks 5 or 6 millimeter long are obtained, and then surround it with a closed box of sheet zinc, not the slightest amount of sparking can be detected. So we're talking about like a Faraday cage, which in even if you cover it in copper in a true Faraday cage, it won't keep everything out. So we've got to do more shielding than just that. And so I'm going to talk about the zinc here, and I think we're done with these quotes. He talks about making a wall of zinc and how it doesn't go through it and so forth. He talks about doing his whole lab room with zinc wall, and how this energy, like I said, would go through, just as we were reading the other quote. It could go into another room. And so this shielding is not only protective of the outside of the box, or the other side of the outside, but it actually assists in maintaining a standing wave. And that's what's interesting here. So let's look at this. Oh, actually, one more thing. So let's quote Tesla. So we're looking at 1892. Experiments with alternate currents of high potential and high frequency. So we're going to go down here, and it's a very interesting read. And of course, I'm not trying to endorse Tesla by all this, but I want to read from him what he says when he presented this device here. Now, he presented something that came from other people. All the different things, including the pancake coil, were not Tesla inventions. So we're talking about a box just like this with a disruptive discharge inside of it, filled with oil, zinc plated box filled with oil, and this is what I want to recommend to everybody. And I think we'll make this available for people if they want it. Otherwise, you can make it yourself, and I'll explain that in a minute how to make it. But let's read the quote from Tesla here. All right, so the appropriate part here. Let's just read the paragraph before it. But of all the discharge phenomena observed, the most pleasing to the eye and the most instructive are those observed with the coil, which is operated by means of the disruptive discharge of a condenser capacitor. The power of the brushes, the abundance of the sparks, when the conditions are patiently adjusted, is often amazing. So you can see these guys are just overwhelmed with this toy that creates this fascinating light that no one's ever been able to see in modern times. So with even a very small coil, if it be so well insulated as to stand a difference of potential of several thousand volts per turn, we can do that even with these little coils here. The sparks may be so abundant that the whole coil may appear a complete mass of fire. So I could show that later on. I'll show how we can create fire with these, even the neon sign transformer. We can create a fire in our hands. And I'll show you later on how Tesla did this in a room where he could create fire right in his hand and his hair. And he did, like Houdini, these magic tricks for people, and it's not actually that hard to do. And I think you can see some videos on YouTube on that. Still is very dangerous to do. It is, of course, out of the question. Now this is the part that I want to bring up. In an experimental lecture with only a few minutes at the disposal of the performance of each experiment to show these discharge phenomena to advantage, as to produce each phenomena at its best, a very careful adjustment is required. So, but even if imperfectly produced, as they are likely to be this evening, they are sufficiently striking to the interest of the audience. To interest an intelligent audience. Sorry. Before showing some of these curious effects, I must, for the sake of completeness, give a short description of the coil and apparatus used in the experiments with disruptive discharge this evening. So again, disruptive discharge is not a constant current system. It's a pulse, opening and closing of a switch, and it's very sharp. So anytime you do that, we create this phenomena, more or less. And if we do it in resonance, then it's greatly heightened. So it is contained in a box of thick boards of hardwood, covered on the outside with zinc sheet, which is carefully soldered all around, which I have some soldered here. It might be advisable in a strictly scientific investigation, when accuracy is of great importance, to do away with the metal cover, as it might introduce errors, principally on account of its complex action upon the coil. Now remember that. It's complex action on the coil inside of this box. As a condenser of very small capacity, so we're talking about the box here, it's like a condenser of very small capacity. It has an electrostatic and electromagnetic screen. So it's both electromagnetic and electrostatic, this zinc box. Very critical here. When the coil is used for such experiments as are here contemplated, the employment of the metal cover offers some practical advantages. He doesn't get into very much detail though here. But these are not sufficient importance to be dwelled upon. So we have to find and look elsewhere for the answer. And this is where I'm saying there is a very important advantage, as he says here. So now listen to the details. The coil should be placed symmetrically to the metal cover. And the space between should, of course, not be too small. If you were to put a coil pretty close to it, it's going to be transferring some of the energy to the material itself instead of rebounding off of it. Certainly not less than, say, 5 centimeters, right? So I made a 1 foot cube box here where we can put something in, and I'll show this in a minute. But much more if possible than 5 centimeters, especially the two sides of the zinc box, which are right angles to the axis of the coil. Remember, right angle is critical in the flow. The magnetic, the magneticity, the flow is at a right angle. That's what we talked about before. It should be sufficiently remote from the latter, as otherwise they might impair the action and be a source of loss. So we want to have enough distance away. The coil consists of 2 spools, blah blah blah, goes on and on. And I want to just say, I'm not going to talk about the system itself because we don't have time to go into all these details. There's not much danger of breaking through the primary and the insulation between need not be thick. Using the coil is advisable to attach to both terminals, equal capacity, blah blah blah. Alright, I want to get down to, so there's oil all around in the box too. We can actually add oil to it if we need to. I think we have a day where our insulation is better quality, so we don't need the oil as much, but the oil may add another capacitive value to this whole thing. A lot of these systems utilize the coil as a capacitive value as well as inductive, and that's important to understand. And using styrofoam and different kinds of insulation of the wire can be a critical factor in some of these different inventors, like Cabananci and stuff like that, people like that, those types of systems. So the oil was of interest, and okay, we're done with that. So let's move on now to, so I just wanted to say that Tesla got this idea of the zinc not from himself but from others before him. I wanted to just quote Hertz on that. And Thompson, Tesla quote. So now let's get into actually running this stuff and do some demonstrations here. So for this I'm going to come out we can look at these meters, look at the batteries. Batteries come back. This battery has finally come back down in voltage to where it was earlier today because it's been sitting for a while. So what we want to do is talk about a few things here. And so, let's see what else should I talk about I missed. So we want to look at this meter here. Okay, here's it. So this is a ghost detector. This is detecting the Gauss of, for example, a magnet. Now I need these because I do shipping of magnets, and you can only have 0.2 to go through the mail system. So milligauss, Gauss. So if it goes past 2 on my meter, then it's too much for the postal service to ship. So you actually have to put steel around it or put the magnets in such a way that, or the box big enough that this meter won't register more than 2 on the outside of the box, especially if you're flying. Don't ever ship saying magnets in the mail because they'll just reject your package. So not looking at this magnet anymore, we're looking at the radiation, the magnetic radiation from different devices. So let's look at what happens with this. Now this is one of your, we started off the last video with this, where you can see, you know, these streamers here, and ooh, cool, really weird, you know. So this produces remarkably a lot. Look at this. Look how far away I am. I have to go quite a distance. It's still registering this far away. Now this is a very cheap meter. I'll show another one later on, but I don't need to show that right now. That gives you really fine point details. But we're at already 3 right here. We're, 2.5 feet away. So now, when we look at the bigger one, watch this. Okay, I turned it off now, see? It's not working. Watch what happens when I turn this one on. It's screaming already. Look how far away. Now I'm about 7 feet away. And it's still registering, still registering. I gotta go at least 10 feet away. It's still registering 1. So this whole room is electrified. Saturated right here. It's all this field. Alright, so we're going to turn that off, and we're just going to run this little one again. Now watch what happens. Look at this. Now, what does that tell you? I'm on the other side. That means the whole air is electrified. Now watch this. A little bit of a crack. Now I've soldered this up. And I'll show you that in a minute. So when Tesla said you have to solder it, he was right. Because on the back here I have it folded, not soldered. And you can detect very little leakage, but right here, it still gets through there. Look at that though. Who let the cat out of the bag? So the transmission is stopping. So the point is, see now I become an antenna. So let's do this. Let's put that tinfoil on this. Yeah, I'm one of those conspiracy theorist tinfoil hat guys. Oh, I had to do that. So we're going to cover this up. Now you can hear it sizzling away in there. Oh wait, let's get a better. So now it's still becoming an antenna. Let's attach this to it. See if this does anything. Not really. It's still giving off some radiation out here though. But anyway, we can create the process So you can see this becomes an antenna. But not to the zinc in that sense. Interesting. But by itself, anyway, I wanted to show that and explain that. Now, let's look at the violet ray device here. The same thing. What I want to show is the bulb lighting up. Well, you can see the bulb light up. Let's get rid of this thing before it drives us crazy. Not much, it would be hard to see it. You can see it lights a little bit. So let's now connect the violet ray up. Watch what happens. Do the same thing. So you can see probably not good for this circuit probably to do that. You know, we could so again, this is going to create streamers. They're going to really bite you. So you can see the tube. So of course I'm a ground. You can still do this without touching it. You don't have to be grounded. But the ground element will be much more additive. So of course, for now what we want to do, put this in here, and again, you can see that the whole area is still becoming electrified on the outside. You know, as if it's close to it, right here. But now, watch what happens. So now, we're pretty close. We're not within that 5 centimeters that he said. We're closer. So we can see this coming. So watch what happens again. See, as soon as I close it up, it goes off. Now I don't have it completely closed. I have to do that. And now we've done that. You know, we've done the same thing. We've closed it up. Now, because it's still open on the side here, I can't get this whole thing in there. So I can't really do that, but I wanted to show at least this thing is still beeping like crazy. But you can see so actually that thing over there, which is only between 2 and 10 watts, that glow plasma bulb produces a much greater field than this violet ray. Now of course if I was to put the violet ray tube in it, we'll see what that does. Let's do the gas tube. This is the rake for the hair. And I got rid of headaches with this within 5 minutes. Migraine headaches. But again, it's not very healthy for you, so producing ozone. So let's look at this now. See, it's still, even with me, I have to be, to get up to 10, I have to be within 2 feet. Whereas that one, 7 feet away. So the point is, with all this, what's my point? 2 things. One is, well, first of all, let me show a couple of things here. So I just made square box, and then I just took a sheet of 48 inch by 12 inch zinc, and then I took another piece and cut it, and I just folded it around. It's not quite 12 inches for this one, so it can fold around, and then I just soldered it. You have to use 85% zinc and 15%, oh, what's the 15% now? I forget. And you have to pre-tin it, not like regular solder. It's a mess. You can grind it down. You want to leave a little gap and do that, but you can see the difference of when I was doing that, that even closing it up, while it shut off most of the leakage, it still allowed a little bit out right here at the crack. So you'd have to literally solder it or make it big enough to fold around the edges like I did on the bottom. And so you could put your cables coming out at some point if you need to access inside of there. You could put a hinge on it. But my point with all this is 2 things. One, that we need to contain this field. This field is something totally different. We're not used to this. We don't use this in hardly anything except for our ignition coils in our car. Our cars that have ignition coils do send out this signal too, and it is not healthy for you to be in that environment. And that field extends on the ignition coil supposedly around a good 15 meters. So your whole car is engulfed by this. So really that isn't a good thing. And but the other thing being the exhaust, we want this ozone exhaust to go outside and other exhaust. So that's my main point today. The other thing being that this field that is created is what we want to tap into. We want to create this field and then we want to tap into it. And so you can see the different devices, these plasma globes, and that one is a very special one, much better than the ones that you buy today because it has adjustments on it. I can change it. And but you can see how much of that of how that field, how big that field is. So we want to be able to tap into this. And this is what we're going to be showing in upcoming videos, is how to convert this energy. Like we see the Tesla coil, it's doing the same sort of thing. It's sending this out. Now I don't have that set up to run like I do everything else here. But the same sort of thing happens, the whole area. Like we showed in our conventions, at the end of our conventions about a year ago we were doing this, where I would get 20 of these tubes, but 8 foot long, 60 watt bulbs. and people would hold on to them within the area of the Tesla coil there, and they would light up to a certain level of brightness under 1 watt of input power from a 9-volt battery.
Is that what we're saying? So how many?
And so they could light that up, producing quite a bit more than 1 watt worth of light. Now, what you can do is you could put the whole Tesla coil in a casing like this, and then you could run 1 wire to all these different bulbs and light these bulbs all up, instead of having to create the whole, and you could use, high tension, high voltage insulated wire to go up to your bulbs, and you could run a whole shop. You don't have to throw away these bulbs, and it won't be running at 60 hertz. And so what we can do is run all those bulbs for next to nothing. So the lighting is very easy to do. And of course we can run even more LEDs than that, because LEDs are more efficient, but these will light up. This is the easiest way to convert this high frequency stray voltage, as they would call it, the magnetic part of the energy. So let me pose this question for those who would have a problem with what I said earlier, quoting Don Smith, about the radio station is not actually transmitting power to the receiver. And he says that in the context of the electron. The electrons at the power station are not coming into your house and circulating. What's happening is they're exciting the electrons over here or at your place, and they're producing the energy in the local environment. So in the same way with the radio stations. So anyway, the bottom line is, we'll be showing some other examples of this. What we want to do is create a receiver of this energy. We want to collect this energy in such a way as to tap into it. Oh, so yeah, what I was going to say was the frequency is not a usable frequency except for gas bulbs. And I suppose you could create heat with heat elements or whatever with a high voltage, high frequency pulsing, but we want to transform this into a usable energy. And that's why people don't know how to do that part. And so they haven't utilized this type of energy. And they just think the only type of energy is electrical energy, and that's not true. It's the magnetic component of the energy that we see being measured with this meter here. And we saw how much there was. So if we take, this is an LED right above me, and I have to be pretty close. Now of course this is only a 6-watt bulb here. I have to be within, so I'm at number 2, within about 6 inches of the bulb. It's not producing a lot. Now if I get closer to this LED over here, that's a 100-watt one, and that is, still you have to get relatively close. So there's not a lot of this energy coming off of this, of regular constant current devices. But with these very low input, high voltage, high frequency systems, we create this huge magnetic field in which we can tap into, especially if we have a resonant circuit that we're tuned into that. And then there's zero resistance, remember, and then you have negative resistance. So you have the ability to have the power come in and charge up. So there's a lot of ways to look at this. People define terms in different ways. That's not my point here. My point is, there is, and I'm trying to show you a variety of ways to do this so that you're not limited to one inventor or one patent or whatever. There's literally thousands of patents that actually utilize an over-unity process, at least in part of their process. And they might not sell it as that, or it may not be an over-unity device in the end, but they're utilizing these processes. So you have to understand, and this is what we want to get into, understanding this in the various aspects of it, to do a very simple system for everybody, an affordable system that will provide everybody's power needs in the whole world. And so if you can really understand that so far, you've got it figured out. From here, we just need to utilize inductors, capacitors, and semiconductors. It can be done solid state. We can use the ground. We don't need the ground, but the ground makes a huge amplification, a very easy way to do it. So there's harder ways, there's simpler ways, and we don't need to get into exotic parts. We can use very simple parts, and we'll show this. Parts off the shelf. So I wanted to show historically, these things, because it's important to see that this has been done for a long, long time. And it's nothing new. This is not something that somebody just figured out. It's not something that I've invented. Now, I'm going to do something with this box, inside of this box, that will also enclose around the object that's producing, and that will actually tap into that energy even more. But what we talked about, what I didn't quote from Hertz was the quotation where he says there's a standing wave between the zinc and the beam, so to speak, in the coil. And so there was an interaction going on here. So that is one form of a enhancement. So we're not losing this potential to all the grounds and all the receivers that aren't utilizing this energy, but it's bounced back. What I want to do is create more than just that standing wave. I want to create an antenna system in which we capture this energy, and I'll show that when it's available as a product. But for now, the zinc box will work, and I think that's everything I want to say today. We'll have a whole bunch of different methods of showing this. Like I said, I want to show the full Carlos Benitez system in this presentation, in which you'll be able to make these systems and power whatever power you need just from that system alone. And from there we'll show some other inventors and some other things, how to do this in different ways. And again, my objective is not to make money here. By sharing all this information, I'm making it available to everybody for free, in which you can build it yourself, or build a variety of these things yourselves, instead of having to pay somebody a lot of money for. So I think we'll make some systems, people can buy them, or we'll sell parts, as we've been doing for over 10 years now. So thank you for watching. I hope you enjoyed it. Give me a like on here. Feel free to discuss all this on the channel, and hopefully spread the word. Subscribe. Do what you can to help in this cause. Thank you very much.